Here we're going to use the unit circle to find the exact value of each trig function. In this one, they're just telling us to do the cosine of 225. So I'm first going to use my unit circle to draw a triangle at 225 degrees. Now I know because this is 180 degrees that 225 is going to be 45 more degrees. So I know that this angle right here is 45 degrees. Now using the special right triangles, I know that this is a length of 1, 1, and the square root of 2. Now the hypotenuse length we always leave as a positive value, but the other two sides of our right triangles are going to be either positive or negative depending on where we're at in the coordinate plane. In this case, both of them are negative because we went to the left on the x-axis, that's a negative value, and we went down on the y-axis, so that one's negative. So now we're ready to find the cosine of 225 degrees. So I'm looking at the adjacent side, which is -1, over the hypotenuse, which is the square root of 2. We have to rationalize that denominator, and so I end up with negative square root of 2 over 2. And we notice that on our unit circle that we see the cosine, the x value of that point is negative square root of 2 over 2. Now we're going to use this unit circle to find the tangent of 5 pi over 6. I'm first going to draw a right triangle going to 5 pi over 6. And I know that this angle is 30 degrees because over here in quadrant 1, we can see that pi over 6 is the same as 30 degrees. And as we keep going this way, anything with over 6 is going to be 30 degrees. Think of it this way. If you split up 180 degrees 6 times, each of those is going to be 30 degrees. So 5 pi over 6, this angle right here is 30 degrees. Using our special right triangles, I know that this side is 1, the hypotenuse is 2, and the other side is the square root of 3. It is going to be a negative square root of 3 because it's going in the negative direction on the x-axis. This side is positive 1 because we went up on the y-axis, and that's positive. The hypotenuse is always positive. Now the tangent, we know, is opposite over adjacent, and so it's going to be 1 over the negative square root of 3. I'm going to rationalize that denominator, and I get negative square root of 3 over 3. The other way to look at it, we saw on an earlier slide that the tangent of theta is going to equal the y value divided by the x value of the coordinate. And so in this case, I can see this coordinate right here. It's going to be 1/2 over the negative square root of 3/2. And to simplify this, I'm going to divide it out as basic fraction division. Dividing is the same thing as multiplying by the reciprocal, and when I simplify, I get -1 over square root of 3, and when we rationalize that denominator, we get the exact same thing that we saw earlier. Your book has this nice handy table to show you what's going on in each quadrant. In quadrant 1, all those values are going to be positive. In quadrant 2, because our x values are negative, our cosine and tangent are going to be negative, and so on and so forth. This is a handy reference, but if you're drawing your diagrams correctly, you won't really need it. So in this example here, we have the angle 330 degrees. That means that this small angle right here is 30 degrees to make that total of 360. So I'm going to draw my right triangle right here. Now I know that this is a special right triangle, a 30, 60, 90 triangle. And so I know the sides are going to be 1, 2 for the hypotenuse, and the other side is the square root of 3. Before we start finding sine, cosine, and tangent, just check your signs. This needs to be a -1 because we went down in the y direction, and this is a positive. It's going to stay positive, square root of 3, and hypotenuse is always positive. Using SOHCAHTOA, the sign is going to be the opposite, which is -1, over the hypotenuse, which is 2. We can just leave it like that. Cosine was the adjacent over the hypotenuse. We can just leave it like that. It ends up being positive. Tangent, we have that -1 as the opposite, square root of 3 as the adjacent, and we have to rationalize the denominator. In this one, we're finding sine, cosine, and tangent of 270 degrees, which is this direction right here. We can't really draw a triangle in this case, but it helps to remember that in the unit circle, if I draw a circle here, the radius, that's not a great circle, but that's okay. The radius is 1. And so each point on the axes, we can write down the coordinates 1, 0, 0, positive 1, negative 1, 0, and 0, negative 1. So this is the one we are concerned about right here. Also remember that the cosine is your x value and the sine is your y value. So cosine of 270 degrees is just going to be 0. Sine of 270 degrees is going to be negative 1. And then remember that tangent is equal to the y over x values. And so that's going to be negative 1 over 0. We cannot divide by 0, so this is going to be undefined. Here we're going to find sine, cosine, and tangent of the angle 11 pi over 6. This is where it's going to be helpful to refer back to your unit circle. But the other thing to remember is that the unit circle is 2 pi all the way around. That's going to be the same in this case as 12 pi over 6. And so I'm just 1 pi over 6 away from 2 pi, which means I'm going to be looking at this angle right here as 11 pi over 6. It's just 1 pi over 6 away from 2 pi. I also know, because this is something over 6, that this angle right here is going to be 30 degrees, which means I have a special right triangle with the side lengths 1, 2, and square root of 3. The 1 here is going to be negative because it's going down in the y direction.